Hello everyone, I'm Xiaoyi Jin. Today I'd like to introduce the basic knowledge and applications of ROADM. This course focuses on the following aspects: the basic concept and terms about ROADM, what CDCG ROADM is, the technical development of ROADM, and different types of ROADM sites. ROADM stands for Reconfigurable Optical Add-Drop Multiplexer. So what is ROADM? Let's use a high-speed railway as an example. In a WDM network, ROADMs are like interchange stations where passengers get on or get off the train for their stop. Passengers are like optical signals that are added, dropped on different ports at ROADM sites in various directions on WDM networks. Next, let's see some terms of ROADM. The first term is colored. In a colored scenario on each local port, only specific wavelengths can be added, dropped, similar to the scenario where passengers get on off the train through different gates, such as ordinary passengers and VIPs during peak hours. Each type of passengers can only get on or off the train through designated gates. Similarly, there are colorless scenarios in which each local port is not wavelength specific, meaning that any wavelength can be added or dropped at each port. In this case, the passengers get on or off through any gates as though it were during off-peak hours. The third term is directioned. In a direction scenario, services that are added, dropped at local client-side ports can only be transmitted in a specific direction. Think of this as a scenario in which passengers change at a small interchange station to or from a specific destination. In contrast to direction scenarios are directionless scenarios, in which service wavelengths added or dropped from local client-side ports can be transmitted in any direction. This is like passengers being able to get on or off the train at a major station without designated destinations. The fifth term is contentionless. In a contentionless scenario, service wavelengths in any direction, including some wavelengths, can be added, dropped simultaneously at local client-side ports without wavelength blocking. This is similar to scenarios in which major high-speed rail stations with multiple gates for each type of passenger allow said passengers to simultaneously board and depart without queuing. The sixth term is flexible grid. The channel spacing of the flexible grid is 12.5 GHz, which can be adjusted flexibly to meet wide spectrum bandwidth requirements of beyond 100G services. Overly large wavelengths can be transmitted through narrow channels, and small wavelengths will cause a bandwidth waste if transmitted in wide channels. Reasonable scheduling is required to raise the spectrum bandwidth efficiency. Let's next take a look at CDCG ROADM. CDCG ROADM stands for colorless, directionless, and contentionless ROADM with a flexible grid. Now let's look at the development of ROADM technology. ROADM technology has involved three core components throughout its development history: wavelength blockers, planar light wave circuits, and wavelength selective switches. These components are based on different technologies, and each has its own pros and cons. Early ROADMs rely on the WB and PLC technologies. Nowadays, ROADMs rely more on the WSS technology. How does WSS achieve the flexible grid? As we have learned, flexible grids implement flexible grooming based on the originally fixed spectrums, as shown in the diagram. The spectrum uses 42.5G spacing as a base unit, implementing the flexible combination to meet the spectrum bandwidth expansion requirement of 400G and 1T services. There are two types of WSS: liquid crystal display-based and liquid crystal on silicon-based WSS. The main difference lies in resolution. LCD WSSs are based on stripy pixel units, and LCOS WSSs are based on rectangular units which support smaller resolution. Before we discuss about 5 typical ROADM site types, let's take a look at FOADM sites. As shown in the figure, FOADM sites allow only specific transmission directions for locally added, dropped wavelengths, and pass-through wavelengths must be manually connected. Fixed wavelengths can only be added, dropped at specified ports. Now that we are familiar with the characteristics of FOADM sites, let's look at the first of 5 ROADM site types: directioned and colored colorless. As shown in the figure, Locally added dropped wavelengths can only be transmitted in specified directions, but pass-through wavelengths can be automatically connected. Local colored or colorless modules allow the adding-dropping of fixed or random wavelengths respectively. System capacities can implement the adding-dropping of 40 or 80 wavelengths in multiple directions. The second type of ROADM site is directionless and colorless. As shown in the figure, compared with the first type, the only difference is the extra WSS module that implements transmission of locally added dropped wavelengths in any direction, and therefore supports the ASON. The shortcoming is the wavelength blocking, meaning that the same wavelengths can't be added or dropped at the same site. The third type of ROADM site is directionless and colorless, avoiding the blocking of different wavelengths. The difference compared to the second type is that another type of WSS is used, allowing the adding-dropping of the same wavelengths on different WSSs at the same site. However, this method only avoids the blocking of some wavelengths. The fourth type is contentionless. At contentionless ROADM sites, M/N devices are used as substitutes to implement non-blocking transmission of locally added dropped wavelengths. That is, any wavelength can be added or dropped at any port. The cascaded M/N devices implement the adding, dropping of all 80 wavelengths in M directions. The last type of ROADM site is the flexible grid type. The networking configuration of this type is similar to the aforementioned types, but with the support of flexible grid wavelengths at local adding/dropping ports. As shown in the figure, the OTM site on the left is directioned and colorless, and supports flexible grid wavelengths. The ROADM site in the middle is directionless and colorless, and supports flexible grid wavelengths. The one on the right is directioned and colorless and supports flexible grid wavelengths. The overall application development of ROADM sites includes 5 stages. The first stage is the colored and directioned, adding/dropping at the specified ports. The second stage is the colored directionless adding/dropping at the specified ports. The third stage is the colorless directionless adding/dropping at the specified ports. The fourth stage is the colorless, directionless, and contentionless adding/dropping at any port simultaneously. The last and current stage is the colorless, directionless adding/dropping of flexible grid tunable wavelengths at any port simultaneously. In order to resolve the high-cost issue of the cascaded WSSs, Huawei ROADM solution uses multi-port adjustable multiplexes to construct TM20, together with TD20, increasing the cost effectiveness. This solution mainly applies to coherent OTN products. As shown in the figure, if fewer than 20 wavelengths are added or dropped at a node, WSM9 and WSD9 can be removed. Huawei has been continuously investing in the Beyond 100G ROADM solution, including FlexRate and FlexGrid. We will not go into that any further. You can look into that on your own if interested. The figure here is a demonstration of a Huawei FlexGrid WSS board. Now let's have a recap of what we've learned in this course. We've covered the basic knowledge in terms of ROADM, CD/CG ROADM, the development history of ROADM, and different types of ROADM sites. Are they clear to you now?